Great. Finally, this is going to be a really short question. Okay, so we have an AP Calculus AB question from 1964. It's very, very old. Question number 9. When the area in square units of an expanding circle is increasing twice as fast as its radius, in linear units, the radius is. Okay, so this problem is much more complicated than it has to be, right? And one thing that might help is when you are doing something like this, try to use the things that you've learned in ESL. So, for example, where's our verb? When blah, 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 blah is increasing. So we've got is increasing right here. Hold on, let me get... Okay. So we got is increasing. Okay, so when what, right? So all of this, of course, is when the area, right? So the area is increasing. I don't really care about all of this. I mean, I guess a circle is helpful. So that when the area, let's just say of, right, an expanding circle is increasing, okay, twice as fast. So that seems important. As its radius, okay? So it's increasing twice as fast as its radius in square units. I don't even really care about that because that's just describing the radius. The radius is, okay? All right, so let me just read this question again. When the area of... I'm going to even make it even easier. When the area of a circle is increasing twice as fast as its radius, the radius is... Oh, well, this problem is so much easier. So, let's do our steps, right? We draw a picture. I know I have a circle. Let me get back to a black pen here. I have a circle. And, of course, the circle has a radius of r. What am I given? So here's the part that is really, really important. So the area, right, is increasing. Well, that means that we are talking about dA over dt because that something over dt is what we use when something is increasing, decreasing, or changing with time. So this area is, okay, so whenever I see is, I know it's a equals, is twice as fast. Twice as fast means that it's double. So, twice as fast as its radius. And if it was a longer sentence, it would say twice as fast as its radius is changing. Whoops. Changing. Whoop. So, basically what this is saying is that dA over dt equals 2 times dr over dt. And that's really the hardest and the most important part of this question. So that's what I'm given, and obviously what I have to find is that last part right there, which is the radius is. Oh, so I just want to find r. What is r? Right? Now, if I'm talking about the area of a circle, then we know that the equation is going to be a equals pi r squared. Some of you have asked me before how you know which equation to write. And when you're dealing with shapes, usually you're going to write the most obvious equation. Related rates are usually not too complicated. So we have a over pi r squared, and I'm going to take the derivative. dA over dt equals 2 pi r times dr over dt. Now, this is where I'm going to do my substitution. So, instead of doing dA over dt, now I'm going to substitute it, right? Because I know this. So I'm going to write 2 dr over dt, right? And that is what is going to equal 2 pi r times dr over dt. Now, if you can do this quickly, then what you will see is that something cool happens, right? Because we have 2 and dr over dt on both sides, so we can actually cancel out. We can divide both sides by 2, and we can divide both sides by dr over dt. Now, what do we have left on the left side of the equation? Do not say, hopefully you did not say 0, right? If we divide all of this out, then what we have on the left side is 1. So we have 1 equals pi r. And so, of course, our choice is going to be r equals 1 over pi. Oops, that's a pi. I don't know. You'll just have to believe me, that's a pi. And so, of course, our choice is C, 1 over pi.